Hello, and welcome to Backer Breaks It Down. In this episode, we're going to look at the law of signs, specifically the ambiguous case of the law of signs. And so this one is all about two triangles. So, what does that mean? So, a funny thing can happen with the law of signs, and this happens whenever you are given two sides and an angle. So, two sides and an angle are sometimes or never sufficient to determine size and shape of a triangle. Okay. If the angle is opposite one of the sides, then there might be one, two, or no triangles determined. Okay. And so they say, imagine that we know angle A and we know sides A and B. We can swing A to the left or the right and come up with two possible results. A small triangle, which is what you're seeing outlined here, and a much wider triangle. Okay, and both answers would be right. So my advice is when you find yourself face to face with the ambiguous case, which is side angle, solve as if there are two triangles. So what does that mean we're going to do? Okay. So first off, I would take the given information and I would label the two triangles in, because I give you two diagrams. So label that angle A is 75 degrees and that side A is 48 degrees and that side B is 49 degrees, and do that for both triangles. Okay. So if this weren't the ambiguous case, the next logical step would be to use the law of signs to find the measure of angle B. Okay, so that's what I'm going to do because I've got my buddy system. I've got that like angle side pair, like I know angle A and I know side A. So my buddy system ratio looks like this: sine of 75 degrees over 48 is equal to sine of angle B over 49. So from here, as you know, we cross multiply and we divide. So ultimately, I'm going to be taking 49 times sine of 75, and I'm going to be dividing that by 48. And this is going to give me sine of angle B. And then I do need to remember to take the inverse of this decimal that I'm about to get. So I calculate 49 sine of 75, divide that by 48, and then wait a second, I don't know the angle measure, so I have to take the inverse sine. And I do that, and I get that angle B is 80.4 degrees. But what if there is a second triangle? Okay, that's a good question. What if there is one? Okay, and so going back to this diagram here, you'll notice we just found angle B. Now we need to find the other angle B, and those two angles are supplementary. They make a straight angle, therefore they add to be 180. So what that means for us in this problem is that this second angle B, yikes, sorry about that. This second angle B can be found by going 180 minus the angle B that I've already found. So minus the 80.4. And so that would be 99.6. So I'm pretending that there are two triangles, okay? And that's where I'm at. I'm at step 2. Pretend there are two triangles and find the measure of angle B2. So we've done that. Find both measures of angle C. Because if you look at our two triangles, we know 2 of the 3 angles. So it's just a matter of subtracting from 180 to find the angles that we don't know. So I'm doing that with my first triangle. And I'm getting that angle C is 24.6 degrees. And then I'm going to do the same thing in my second triangle. And this will basically determine whether or not there are two triangles. Because if the second angle C comes out to be realistic, then there are two triangles. And what do you know? I got 5.4. So this is a 2 triangle situation because all 3 angles are realistic angles. So I'm going to finish solving each triangle using the law of sines. Okay, so let me just create some space to do that. Okay. And so I'm going to start with this triangle right here. So I can still use that buddy system ratio, sine of 75 over 48. But this time I'm finding side C1. So that's going to be opposite the angle that's measuring 24.6 degrees. That's where you find side C1. So I'm going to do my usual math where I cross multiply and divide. So ultimately I'm going to be multiplying 48 times sine of 24.6. And I'm going to ultimately divide that by sine of 75. And this is going to give me side C1. So 48 times sine of 24.6 divided by sine of 75. I get 20.69. And that would be the that'd be the measure of side C in that first triangle. And then I want to repeat and do the same thing, but for the second triangle. So notice that I'm still going to work with that buddy system ratio of sine of 75 over 48, because that hasn't changed. But this time I want to find side C2, that's side C in the second triangle, and that's opposite that side that measures 5.4 degrees. So sine of 5.4 degrees. So from here, I do the usual math where I cross multiply and divide. So I'm going to calculate 48 times sine of 5.4, and I'm going to divide that by sine of 75. And this will give me the measure of side C2. So calculating, I get 4.68 for side C2. And that's how you solve the ambiguous case when there are 2 triangles. In the next video, I'll go over a 1 triangle situation and a no triangle situation. I'll see you then.